of RAN engineering at AT&T, and he has a lot of experience thinking about software RAN and the problems associated with doing that. I don't think Dr. Chi is unknown to anybody at 5G Forum, and Udayan is also, I think, is a fairly well-known personality, but among other things, he has the distinction of being an Intel fellow and manages a lot of the wireless and software thinking associated with 5G and mobile networks at Intel. So let's dive into the panel for today. So our topic is virtualization in 5G for 5G network architecture, and we've already seen this morning that we're still trying to get our heads around 5G. But given whatever we know about 5G, I'm going to do a little bit of level setting and then we'll dive right into the questions. So can I get my presentation, please? Okay. So I want to start by quickly doing a bit of level setting, and we'll look at 4 or 5 different things around 5G to help us understand the questions that we want to finally tackle with our panel here. And the first thing is, okay, let's talk about the characteristics of 5G. So, while it can be defined in many ways, there are 2 or 3 different things that are becoming clear that are going to happen, and that is there's going to be a proliferation of different kinds of services in these networks. We will need to have context-aware services, and the networks will have to kind of follow the user in the sense that the user experience is therefore going to become key in these advanced 5G networks. And then, when we think about use cases, there are 2 or 3 use cases that come to mind and that have been defined, and they're quite distinct in their requirements. So the first is just enhancing the mobile broadband speed, and speeds as high as 20 gigs per second per UE have been proposed. So that's a really, really large number if you think about it. The other application is massive IoT, where the idea is you have a whole bunch of sensors that have potentially millions or billions of them that have to be connected over a wireless network. And that requires, is used for, let's say, remote industrial monitoring and a variety of other applications. That has one kind of application where you have very low bandwidth communication from multiple devices. And then there's mission critical IoT, where the idea is that you have a very low latency and extremely highly reliable communication. Potentially for things like vehicle-to-vehicle communication or intelligent transportation or industrial IoT, where you cannot afford to compromise on the reliability of your communication mechanism. So these are kind of the use cases we tend to think about, and then what are the problems that the operators as a whole are facing today? Well, there are a few of them that relate to our discussion here. One is that they have to manage disparate networks, 2G, 3G, 4G, potentially Wi-Fi, and maybe even fiber networks. And that's always a challenge because you can't really, you have to have different mechanisms, different teams to do that. And it's complex, it's expensive, it's hard to scale. The other is you have to over-provision resources typically by a factor of 5 to 10 because you're designing for the worst case. There's no flexibility to pool resources and bring them together and use them flexibly. And that's a huge cost as economics becomes a barrier, as we all recognize. The operators are really worried about revenue and profits. And finally, there's the change in traffic patterns that is expected with these new kinds of use cases, where you move from more a hub and spoke pattern to a more meshy pattern. And there's communication between base stations, across base stations, in the metro network, and so on. So these are sort of the key problems. And the other is the inability to add new services flexibly and easily. So these already motivate us to think about, okay, something needs to be done in the network. And virtualization is one way to start solving some of those problems. So the motivation for virtualization for 5G actually come from the use cases that I talked about earlier. So if you have ultra fast speeds, you need to worry about now what is going to be your front haul capacity. If you need to go from the radio head, let's say, to the base station, as you start separating them, you need a very high capacity in the front haul, which means you have to think about new mechanisms to do that, right? And you have to think about how you're going to split functionality between the radio resource or the radio head and the baseband unit. Same, the ultra-high bandwidth also has an implication for backhaul, because if all of that bandwidth has to be backhauled, in the way we do it today, that's going to explode your backhaul bandwidth, which again pushes us into thinking about maybe distributing our computation, distributing the network functionality somehow in the network. And finally, when you have ultra-low latency, Well, how are you going to achieve that as your network expanse grows? That means you have to eliminate the backhaul round trip, and again pushes you towards somehow distributing your computation and distributing features and capabilities and maybe virtualizing things. So that's really, when we think about virtualization, where do we virtualize, how do we virtualize? Those are the key questions. Well, you'll see in a minute that you start by virtualizing both key core components of your network, the core network as well as the radio access network. And typically you do that, as I said earlier, by distributing initially the functionality of the BTS between a radio head and a baseband unit, and then pooling in the baseband resources to maybe use them more effectively, and converting them into kind of a server-based architecture. And then eventually you can create virtual slices per application so that you can now have essentially different networks with different properties for the different kinds of use cases that you want to worry about. So this is a very complex slide, but the only thing I wanted everyone to take away from here is this is where we are today. We have this simple, the distributed RAN architecture. You have the base station, you have the user here at the bottom, and then you have the backhaul and the core. As we move towards more virtualized architectures, we're going to go into what is called the cloud RAN or C-RAN, where you are separating, as I said earlier, the radio head from the baseband unit, and now you have to worry about front haul. How do you connect them? How much of the functionality goes to the radio head versus the baseband unit? And as you move even more into the kind of use cases we are talking about, you're going to also start worrying about virtualizing and distributing the core. And there are various ways you can do that. You can distribute the core into the edges. You can distribute the control plane functionality. You can distribute the user plane. So many options to do that. And finally, once you've kind of distributed your core and you've virtualized it, you can replicate those virtual slices, which is what you see at the extreme right for you. And you can create slice networks, one per application, for ultra-high band, high-density video communication, a different one for voice, different one for massive IoT, and yet another one for mission critical, because they all have different characteristics. So that's kind of the level setting that I just wanted to do. And what you need to do here is that you have to think about your front haul. Oh, I'm sorry. You have to think about front haul differently. Maybe you have to bring a packet-based architecture as opposed to, let's say, CIFRI that we use today. You have to think about your backhaul. How are you going to reduce capacity needs on backhaul? How do you distribute functionality, into the edges? And how do you, minimize delay? So that kind of sets the stage for where we are going to go with this panel. And let me then go on to some of the questions very briefly that we'll try to tackle here today, and then we'll dive into them. So what we want to talk about is, okay, with virtualization, what do we need to do? What do we want to deliver for 5G in the core today? Is it going to be in the core? Is it going to be in the RAN? Where will it be seen first? What are some of the key aspects of virtualization if you want to enhance user experience? And then, of course, our title said SDN NFV. So, where do SDN NFV play a role? And is virtualization exactly equal to using SDN NFV? And then finally, what are the challenges? What are the drawbacks? What are the difficulties we still have? And we all know that there are challenges. And maybe there are opportunities as well. And finally, what does it cost? There's a cost in terms of new training, equipment, etc., etc. So let me just sort of dive into this and start off with the panelists. The first question I'd like to throw at the panel is, what is it with virtualization? What do we want to deliver for 5G? In the sense that, what will we want in the RAN? What will we want in the core? Maybe Sinan, you can kick it off with some thoughts.
Sure. I think I'll touch bases for the RAN part. The expectation at the moment, at least as a RAN person, is to see some kind of separation between the control plane and the user plane, which will enable us with an agile platform to get the new services or the changes or this new management network control mentality out into the field faster and with efficiency. That's the first thing that we want to see. And then, of course, there's this front end where the cell sites, where we have the baseband units today. They're all in the field. Nobody can say that this is the most efficient way to design the wireless network. We're designing the cell sites for their busy hour at the moment, per cell site. We're not designing the whole network for the network's busy hour. The efficiency, in my opinion, is the king for the future. So there's a lot to be gained once we have an SDN-based system out there, because you don't really have to have single baseband units at every cell site. And maybe later on we can talk about the ecosystem with the separate component with the OEMs, but the basic expectations for RAN is to have an agile platform for the control plane and a separate commodity product-based plane or system or a space rather for the cell sites.
Sure. Okay.
Okay. I know it's a short panel, but before I answer, can I ask the audience a question? How many of you are semi-experts of virtualization technology? Raise your hand. Okay. And how many of you are kind of on the beginner slope, the learning, I mean, as a student of this technology? Okay, the rest of you, where are you? Super experts. Well, I want to ask a question because I truly and really sincerely consider myself a student of virtualization technology, unlike there's a master here. I think virtualization, or SDN NFV, usually the 6 letters gets spelled out together nowadays, is something that came out of IT industry. And we as, not counting you, we as the city industry representatives, we are trying to learn how to benefit from the efficiency and the agility of this set of technologies. But exactly how to introduce it in, how to migrate, is different from how to design a greenfield start.
Sure.
So we are actually right now looking at 2 types of challenges. One is how to bring this technology into our existing network ASAP, because we really need to become greener and softer. You know, these are my 2 favorite words. If you have heard me talking, green for efficiency, end-to-end, soft for agility, end-to-end. How do we benefit from this technology in our current network? And the other is taking this as our starting point, designing a revolutionary way of a new network architecture end-to-end. These are 2 different types of challenges. And like the earlier session this morning, we challenges their opportunities, and we take the 1 step at a time. And I think for our current network, for example, we are doing detailed analysis of cost-benefit challenges, I mean, in terms of how difficult it is versus motivation, which comes from how much you gain. So if you look at the current core net, for example, you look at IMS, you look at the EPC, and you look at the CS domain, they are all very different. So I can tell you currently we are focusing on the relatively low cost or / challenging and relatively high return and strong motivation, which is actually the IMS control plane, so to speak. Okay. And for the next generation, I believe certainly the control plane, hopefully not just the core network, but also the RAN as well, would be where this set of technology can help us have the good design, green and soft. And in addition, probably even we can get to the higher layer protocol stack in addition to the upper layer applications. Okay, so we are looking very carefully at L1, L2, L3, the traditional protocol stack, to see where we partition for the feasibility of virtualizing versus not. And I have a talk this afternoon, maybe, hopefully I can share a little bit more of it.
Yeah, thank you. As Dr. Yi and Gus said, that it started from the data center and the IT industry, but some of the benefit that they have received, people like Google's, Facebook's, and IT's, we want to get a similar kind of benefit, the increase in utilizations, the redundancy, also in RAN and code. Now, there are all these terminologies being thrown around, like in SDN and NFV are two separate things. SDN essentially is separation of this control from the data side of it, so that you have centralized controller, started from the routers and menus. And then network function virtualization is basically having functions like RAN, like core, like S gateway, P gateway, or MME are as a virtual functions. So they go hand in hand, but they don't have to be together. Right now, the concept of SDN, we are trying to bring it into RAN and core. NFV portions is there in core. I mean, we started virtual EPC, virtual core. In the RAN, as Dr. Yi mentioned, we started looking into the higher layers, where there are a little bit of relaxation on some of the TTI and end-to-end latencies. So we started with that. The other thing that we are doing, as I think you mentioned, ecosystems, just to touch on that, we are working with people, the virtualization vendors, as well as our own intercompanies like Wind River and others, to actually bring some of those jitter and latency down. So, data centers may not, or Amazons of the world may not have cared that level of end-to-end latency that I need here. So we are working with those ecosystem partners to actually optimize on the software, as well as on the silicon side, add more features on the silicon.
So I guess a couple of things we want to answer that, it seems that starting from the core, it is, control plane and then data plane as we think about the various layers in the data plane and so on. And then I guess one of the key aspects we all talk about is the user experience, right? So, what are we trying to do? And you kind of touched upon that, so maybe we can expand on that, which is what are we doing maybe or thinking about in the RAN and in the core that's going to enhance the user experience and the quality of service or the quality of the user experience. So,
From RAN perspective, I think one expectation from the virtualization is an improved way of controlling the customer experience. And this is going to be a user-centric, if possible, down to a user-based KPI-centric control mechanism. We have some sort of mechanism in the system as of today. I'm not saying that it doesn't exist, but we're still looking at the network from network perspective. We're still controlling the network from the network performance indicators perspective. I think the whole new architecture will improve the customer-centric, the user-centric methodology to a whole different level.
I can't agree more. Definitely, for user, hopefully, first of all, user doesn't know what we did. They flow through our infrastructure and get the best connectivity at the lowest cost, highest performance, everything wherever it is. Of course, that's the ultimate goal. But some specific mechanism, for example, I will also share a little more detail with you later in the afternoon, is that, for example, one of the work we're looking at, we call it Rethink Protocol Stack. We are reconstructing the layer 1, layer 2, layer 3 protocol stack in terms of its partitioning and its functionality, exactly because we expected that the next generation or the evolved, the current generation RAN architecture will have the flexibility and topology to enable a truly user-centric environment. One specific point, let me just highlight a little bit, which is, do you know that currently our network always assume you belong to a particular cell? When you come into the network, first they identify which cell you belong to, and then everything starts from there. So it's the self first, then the user, okay? In our Rethink Protocol Stack, reconstruct protocol stack, it's you first. You don't belong to any cell. Cells will belong to you, and more than one, possibly simultaneously. So it's a kind of flip upside down kind of approach. Well, this certainly will increase complexity and demand on the network side. So hopefully, with the new IT technology, somehow we can get over that hump gracefully.
So maybe Udayan can expand a bit on that aspect.
You know, this user-centric view, I mean, the stuff that we are seriously looking to, and a reorganization of the protocol stack, a lot of anchor booster stuff that you're still tied to, you know, one of the anchor, maybe Cloud-Run anchor, then you data transfer from, you know, small cells to small cells. You're not really doing handoff. All of these elements, I mean, require some form of agility and elements of it. There are technologies like virtualization can help, but the challenges as well. Things like the VM migration now. Truly, if I want to bring in virtualization and RAN, I mean, if you want to increase the utilization and also reduce some of the cost, you should be able to migrate the cores to the VM as the demand increases. As the demand goes down, I should be able to take the CPU core out of that virtual partition and move it to somewhere else. Well, this VM migration exists today, but this takes time. So one of the technologies that we're seriously looking into, again, jointly with China Mobile and others, is looking to how do we actually reduce some of those, not just jitter and interrupt latency, but also the migration time. If I truly need to migrate from one machine to another machine. There are ways of reducing it today. You can pin down the core. There are a whole bunch of, and in the afternoon, I think we have a session as well that Dan talks about it. But I think the technology is evolving quite a bit. And surprisingly, just to add to this, some of the features that we're seriously looking into, these things like migration, some of the latency stuff. Now, our data center so-called customers, some of the big ones, had also started asking for this. Well, great, we will use it. Hey, we have applications too. And the other thing, if I may, is this mobile edge compute. In 5G is all about services. You touched on that. These are network slices. Your mobile broadband, along with that, you will bring in services like connected car, healthcare, connected healthcare, IoT. These are nothing but virtual functions. By the time in your L1 stack, in RAN, by the time you have PDCP, you get the packets essentially. You can truly do whatever you want to do. There'll be some re-architecture you need to do, but you can do a whole bunch of stuff. You can tap that packets there, you can tap it in S1AP. So a lot of opportunities open up, and virtualization can bring in those platforms to actually run those services there as well.
So that is what allows us to move into a much more user-centric mode of operation than we are today, where it's really all quite a bit network-centric. Okay, so I guess, and I think you all have touched on this already, but we talk about SDN NFV as enabling technologies, but is virtualization equal to SDN NFV? I mean, there's more to. My thought was that there's more to virtualization than just sort of SDN NFV. True. So maybe you can address that part of the confusion.
If you remember NFV is network function virtualization. That's virtualization. So you essentially take a network function like RAN in ideal mode or P gateway or some elements of core network and virtualize it, put it in the virtual partition. Now virtualization comes in different flavors. You can have a well-defined virtual with 4 core, which we call it in virtualization parlance, pin down the core so that you don't move things around, so that you get better latency number, lower latency numbers. SDN concept, some of the things that Stanford showcased in Mobile World Congress, we worked with them as well, is called soft RAN, elements of it. So essentially SDN concept, you take some of those control aspects of the elements of that, not just the PDCCH, but in the control aspect buried into your user mode as well. And how do you centralize some of this, through a controller? That's the SDN concept. Comes into play. That's we started those things in routers and others with companies like Cisco, but those aspects are also part of it. So these are terminologies. Network function virtualization, but the underlying technology, there are many different technologies you have to bring it to bear. Some of the things that the Cloud-Run taught us, back in 2010-11, Dr. in the China Mobile is seminal paper, and that Cloud-Run paper, and then we worked together. A lot of things we learned from there. split RAN. Where do you split? You know, how far do you really centralize everything or not? Now, CRAN didn't start you. We absolutely have to have virtualization. Absolutely, you centralize it. But then the next phase is, hey, I've centralized it. Can I use the same platform to actually create a virtual partition so that I run services there? So I think it becomes a natural progression.
So I guess one of the other things is, you know, what are the deployment sort of risks and opportunities? You've already talked a bit about them, but you know, we are changing the core, we're changing the RAN, so it'd be worthwhile to kind of address some of those issues as well.
Opportunities and risks, yeah, they come together, but I think the Chi likes that point too. It's like the changes on the CIPRIS standards and all. So there's a lot of unknowns out there, but I think the real opportunity, I mean, maybe the challenge that I see today is the front end of RAN. So there is a limit on your virtualization. Right? You can pull your baseband units back, and then you can virtualize some of your resources and your control plane on the virtualized space. But then you have this commodity products that are running your user plane. But this, at the end, will be connected to your power amplifiers. And your air interface is never going to be virtualized. So I think what we need to discuss is what are the new opportunities with new protocols that may replace CIPRI in the future. I don't know. I just heard there's a new chapter in IEEE. You may tell us more about it. And then, you know, where is the OEM, where is the other vendors, and where is the operator in this new ecosystem? That's what we need to look at.
Maybe let me just follow up on that IEEE thing so I can have the advertisement here. No, on behalf of IEEE, actually, there is a new standard working group, 1914, that was officially launched beginning of this year, addressing exactly the next generation, you call it CIPRI or front haul or mid haul or back haul, anyway, next generation X-haul network requirement and function partition.
So that was launched just this year or early end of last year?
This year. Well, actually, it was targeted to launch at the end of last year, but there was a little glitch in the logistics, so it's officially launched just this year, the beginning of this year. And it's led by China Mobile, but we have, I think, 7 co-founding initiators. Currently, there are maybe 70 subscribers from 30 plus different companies already, including, I believe, everybody here on this platform, as well as all the major vendors, operators, chip vendors as well. But it's not just a point event happening, because related to that, in ITUT, last year they launched a IMT 2020 focus group where one of the key focus is also on this aspect. So ITUT is working on the transport, supporting this transformation, and with the current ongoing feverish 5G activities in 3GPP, including the RAN 1 face-to-face meeting 1 week long, this week as we are meeting here. RAN 1 is meeting in Busan, and I believe this is also a key topic that will be discussed.
But I guess one of the things that one thinks about then is that we have all these parallel standardization efforts going on, and there's technology evolution happening, so that itself presents some kind of a challenge. I mean, for the operator's perspective, you know, how do you keep sort of doing POCs and thinking about it? When do you sort of bring it into your network? So I wonder if there are some thoughts on that from the panel, or you know, Udayan, in your experience working with different operators, you know, what are you seeing in terms of adoption?
Before I hand this to him, let me just say one thing very quickly. I believe 5G era belongs to more than 3GPP. Okay, 5G era requires multiple SDOs, multiple organizations, even multiple industry segments to work together, because the vision that we all have for 5G era It's just too all-encompassing. I don't think any single organization can have all the answers.
Yeah, that's very true. In fact, actually, the NGFI work actually prompted 3GPP also to look these things seriously. Now, in the context of 14 and 15 and any kind of 5G discussion, the split RAN is an essential part of that discussion. We in Intel, we have multiple, you talked about POCs, we have POCs. One POC is simply tunneling CIPRI over IPv4 and IPv6. So no change on the CIPRI. This is how we started. And actually there is an IEEE, I believe, 1904.3, which was originally doing nothing but tunneling CIPRI over Ethernet. And yes, we founded it. Then we realized potentially that the question arises that is CIPRI, is the right thing of 5G going forward. Well, the standard body is going to, discuss that. But then we also have another POC just where we do some front end. So you bring in the IQ data, which is CIPRI. You do FFT, IFFT. By the time it's not CIPRI anymore, and you bring that over Ethernet. So we have multiple of those, protocol stacks, and then splits running. But we're looking forward the standard bodies to work together and to get those things to a standard form.
Cool. So we have about 5 minutes left, so let's open it up to maybe some questions from the audience as well, so they have an opportunity to ask you. So if there are members of the audience that have some questions for our panels, then this would be a good time for us to field a few questions, maybe 2 or 3 questions.
I wanted to, is it on? Good. Okay, Bear Jaivazian again, Wireless 2020. I wanted to pick up on the point that it's way beyond 3GPP to define everything. And when we're talking about virtualization, I'm sorry, you can't hear me?
I'm in trouble.
This mic. Is it on now?
Yeah, it is.
Oh, very good. Okay, so one of the questions I had is, since virtualization really was adopted in the wireless industry very late compared to the IT sectors, and in fact, other sectors are much further along in virtualizing. And if it is, let's say, more inherent in 5G for things to be virtualized, would you imagine that in the 5G era, the continuity, or let's say seamless virtualization between domains will be a characteristic of the new environment in which the virtualization of mobile and wireless technology elements would be more seamlessly interconnected with those in the IT sectors outside of the wireless domain? So that in fact, if I'm in the automotive industry, my view of the environment crosses from my technology into the mobile domain and is in fact interacting seamlessly with that because it's all virtualized, it's all part of one seamless environment. You see that happening kind of thing where the ecosystem is much broader and virtualization is not just something going on within the wireless domain, but it's across multiple domains?
I'm compelled to first have a disclaimer, okay? So about the 3GPP statement, entirely personal, not on behalf of China Mobile in any way.
I'm sorry, I already tweeted it.
Okay.
You're in trouble.
Yes, okay. I'm going to update my resume. Okay. My statement about that is really that, yes, you will have a kind of end-to-end, all-inclusive 3GPP version of 5G, and also 5G Advanced, 5G Evolved, 5G Pro, and so on, as we have always done in our industry. But really, 5G as compared to the previous generation, there is a major fundamental difference, a new DNA. Before, we were basically on similar track going from generation to generation to boost up a relatively uniform horizontal platform for everyone. And by the way, we may serve some vertical industry just by small tweaking here and there. But 5G, from the starting point, we want to do even more turbocharged horizontal platform as well as all this vertical platform explicitly, but elegantly in network slice fashion, okay? It's a good goal. How to do it, we don't know yet. We are working on it. But because it involves lots of vertical industry, I truly believe there will be a lot of domain knowledge that we still need to acquire, right? Beyond the traditional 3GPP community. So we need really across industry and across alliance, all kinds of partnership. And under that light, IEEE is just a small example, because you cannot say that IEEE never played a role in the previous generations, or for that matter, IETF, because many of the IETF or IEEE standard technology were just made use of by 3GPP as part of its component or underlying assumption. So, but this time around, maybe there will be a more explicit role in some of the specific scenarios, specific components in the network where IEEE and IETF may, play a bigger role, bigger contribution, so to speak. Now, in terms of virtualization, I think really, you said it right, and also Daniel also mentioned that. It came out of, for example, maybe not only, but primarily the OTT industry, the data center realization, okay, the SDN NFV and all of that, met with great success in that kind of environment. Now we want to bring that out in a wide area network, including core, including fixed and the mobile, and all of these new components. So there will be new challenges that are different. The latency requirement is order of magnitude different. Okay, the reliability may be different too. I'll quote a wise man from Facebook, a good friend of mine. He said that from them, it's always better having something than waiting for the perfection. But our industry came from how many nines? I don't know. We're always talking about how many nines. So I think going forward, we also need to learn where we must have the nines, where we don't really need the nines, right? To make us much more flexible. There's a lot of things to be learned, but I think to make it short, the latency requirement in many cases will be much more challenging than the data center per se, even though my friend in Baidu or Google may say, no, they are bringing in accelerator as well now for their data center. But a lot of the connectivity requirement, compute and storage, all of that, I think we want to reuse as much of the experience and the learning as possible from them. But there are new challenges for us to try to bring it into our end-to-end network. And we are working very hard. And actually, I'm very thankful that Intel has been a very close partner since the very beginning, I think 4 or 5 years ago. Yeah. And of course, we have a domain 2.0 here that I'm sure Sina has a lot to say about.
Thank you.
So any other questions from the audience? Okay, great. So let's thank the panelists and break for lunch.